Pluto knew it was coming from the start. Pluto's circle crosses that of another planet. Astronomers are getting excited about the mysterious Pluto, a small planet far out in space from our solar system. Scientists and space enthusiasts are concerned due to recent reports suggesting a possible encounter with Neptune. Michio Kaku and other well-known scientists have raised concerns about the repercussions of this cosmic event. However, how did Pluto end up on a collision course with the planet next to it? And what implications might this collision of the stars have for life on Earth? Come along with us as we learn how a massive object recently collided with Neptune and why this cosmic anomaly has scientists concerned. Due to its peculiar orbit, Pluto was reclassified as a dwarf planet, having previously been regarded as a full-fledged planet. The astronomical community is still captivated and intrigued by Pluto despite this demotion. Recent predictions made by well-known scientists like Michio Kaku and Neil deGrasse Tyson have raised concerns about the possibility of a collision between Pluto's and Neptune's paths, pointing to the imminent threat of a collision that could have significant effects on Earth. Because it is the only Pluto in our solar system, its trip around the Sun stands out. Its orbit lasts a staggering 248 years, making it extremely long. Pluto has not yet completed a complete revolution around the Sun since its discovery in 1930. The fact that its orbit is so much longer than that of the major planets, which are more circular, adds to its mystique. Additionally, Pluto's orbit deviates 17 degrees from the ecliptic plane, resulting in a path that is steeper than that of other planets. Pluto's exceptional circle is made sense of through its mix of tendency and circular shape, which acquaints layers of intricacy with its orbital example. Its periodic intersection with Neptune's orbit is one interesting feature. Contrary to expectations based on their respective positions in the solar system, Pluto moves closer to the Sun than Neptune for 20 years during each orbit. It is fascinating to observe that Pluto's orbit is not a perfect circle but rather an elliptical shape more resembling an oval as we delve deeper into its details. Throughout its journey, Pluto's distance from the Sun varies significantly due to its unique orbit. At its nearest approach, Pluto goes inside around 30 cosmic units, AU, of the Sun, while at its farthest point, it arrives at north of 49 Australian dollars away, 2 times the distance of Neptune from the Sun. Additionally, Pluto's circle is leaned at a point comparative with the circles of the significant planets in our planetary group. Not only does this inclination make its orbit more complicated, but it also plays a crucial role in how it interacts with other celestial bodies, especially Neptune. At the point when Pluto runs into Neptune, their gravitational pulls impact one another, modifying their directions over the long haul. The dynamic nature of our solar system is exemplified by the intricate dance between Pluto and Neptune. While Pluto was once viewed as a solitary vagabond in the external reaches, its nearby experiences with Neptune feature the interconnectedness of divine bodies, each applying gravitational powers that shape the ways of others. Astronomers have been able to more precisely track Pluto's movements in recent years thanks to advancements in observational technology. This has prompted a more profound comprehension of its circle and its possible ramifications for the soundness of the external nearby planet group. While the probability of an immediate crash among Pluto and Neptune stays low, the chance can't be totally limited, provoking kept checking and concentrate on by the galactic local area. Pluto continues to pique the interest of both scientists and astronomers despite its small size and distant location. Why hasn't there been a collision between Pluto and Neptune? The answer lies in the pull of other planets' gravity. Cosmologists started concentrating on Pluto's way not long after tracking down it, and its course confused them. Dissimilar to most planets that stick near similar plane as they circle the Sun, called the ecliptic plane, Pluto stands apart with its lofty point and oval-molded circle. When they discovered that Pluto's path crossed Neptune's, the mystery intensified. Pluto's orbit remains stable in spite of these difficulties, demonstrating the intricate mechanics of space. It is difficult to comprehend the gravitational interactions and motions of 3 celestial bodies, such as Pluto, Neptune, and the Sun. It's like trying to guess where they'll end up based on how they pull on each other and where they start. This challenge demonstrates for Pluto how the Sun's pull, Neptune's path, and Pluto's own path interact. Terms like apsidal libration, scope libration, and the VZK wavering assist researchers with addressing this astronomical riddle. Planets need apsidal libration to stay in their orbits. Pluto is at least 90 degrees away when it crosses Neptune's path, preventing them from colliding. In order to reduce the likelihood of a collision, latitude libration ensures that when Pluto approaches Neptune or other significant planets, it is well above their path. The explanation for why Pluto's orbit appears odd but stays the same over time is the VZK oscillation, which is named after the scientists von Zeipel, Kozai, and Litov. Space is chaotic, but some rules and patterns keep things in order. Pluto's orbit is stabilized by these rules, preventing collisions with Neptune or changes in its path. Pluto is a good example of the concept of orbital chaos, which shows how a celestial body's path is very sensitive to where it starts. Over a long period of time, even minor adjustments to its speed or position can disrupt its orbit. To determine how Pluto moves through space, researchers use computer simulations. The way Pluto and other space objects, like Neptune, interact is modeled in these simulations using intricate math. Astronomers are able to see how even minute adjustments can alter Pluto's path by adjusting these simulations slightly. These simulations discovered something intriguing about Pluto's orbit at the end of the 1980s. Pluto's orbit can still be unpredictable, despite the fact that there are factors that should keep it stable. Over many years, even a small change in where Pluto begins or how quickly it moves can have a significant impact. However, Pluto's orbit remains stable for billions of years, despite all this chaos. This suggests that Pluto's orbit around the Sun is arranged in some way, despite the fact that it appears disorganized. Foreseeing what will occur with planets like Pluto, which have awkward circles, is hard. It is difficult to predict what will happen in the long run given these systems' extreme unpredictability. Simulations not only allow us to get an idea of what might happen, but they also demonstrate that we are unable to accurately predict everything. Simulating complex dynamics, these models require precise starting points. Indeed, even a small slip-up can prompt very surprising outcomes, which makes it hard to make precise forecasts. When considering the possibility of Pluto colliding with Neptune in the future, it is critical to comprehend Pluto's orbit. This information assists us with seeing better the way that our nearby planet group works. It is not a perfect circle because it has a more oval shape. In some cases, it even approaches the Sun more closely than Neptune does. Because Neptune is also out there, cruising along its path, this can make things difficult. Pluto and Neptune may come into contact with each other at some point. Pluto keeps its distance from Neptune most of the time, despite its peculiar orbit. The so-called gravitational forces are to blame for this. Similar to an invisible force, gravity draws objects closer together. So despite the fact that Pluto and Neptune could appear as though they're on a compressed lesson, their circles are painstakingly arranged moves, directed by the draw of gravity. We learn from Pluto's orbit that space is full of surprises. A delicate equilibrium of forces may underlie what appears to be chaos on the surface. By concentrating on Pluto's circle, researchers gain experiences into the multifaceted mechanics of our nearby planet group. Expanding our understanding of the universe and our place in it requires constant observation and analysis. It would be a cosmic event that would shake up our understanding of the solar system if Pluto and Neptune did collide. Pluto's situation demonstrates that we still have a lot to learn about space, despite our progress. We can learn a lot about our solar system as a whole by studying how large planets affect Pluto's path. It demonstrates that the movement and location of each planet can alter the paths taken by other objects in space. Despite the complexity of space, top scientists are concerned that Pluto might collide with Neptune. Even though it seems unlikely, this leaves them wondering why this could happen. Famous space scientist Neil deGrasse Tyson has some interesting ideas about Pluto. He believes that reclassifying Pluto as a dwarf planet rather than an Earth-sized one is a step in the right direction. He is of the opinion that there is always new information about how things move through space. Tyson sees Pluto's strange path as a sign that we still don't know everything. He believes that studying space is so exciting because of its mysteries. He is also aware that people become interested in astronomy as a result of significant space events like Pluto's reclassification. Tyson wants to help people comprehend the fascinating and occasionally bizarre aspects of how space works. He believes that talking about how space mechanics can surprise us is important. Tyson collaborates with other scientists to educate the public about the potential dangers posed by Pluto's peculiar path. He has spent a lot of time studying Pluto and is concerned that it might one day collide with Neptune. He claims that this could pose significant challenges to the entire solar system. An accident among Pluto and Neptune would be an interesting and serious occasion. It could destabilize Pluto and release a lot of energy. The crash's fragments could travel through space and strike other planets and moons. Neptune could likewise feel the effect and change how it moves. Tyson is attempting to persuade everyone to pay more attention to Pluto and the potential outcomes of a bad situation. A catastrophic collision between Pluto and Neptune would have far-reaching effects on our entire solar system. Pluto's demise could result from the immense amount of energy released by such a collision. The impact debris could be dispersed throughout the solar system, posing a threat to other planets and moons. Neptune itself could be undermined, changing its circle and possibly causing a far-reaching influence all through the external nearby planet group. Tyson emphasizes the significance of ongoing research and monitoring to comprehend the potential dangers and devise strategies for mitigating such devastating events. Tyson hopes to avert any calamity by increasing public awareness and encouraging scientific community collaboration. It is essential to keep an eye on how celestial bodies like Pluto and Neptune interact with one another as we continue to investigate and gain a deeper understanding of our solar system. Understanding these elements can give important experiences into the activities of our grandiose area and assist us with planning for any potential difficulties that might emerge. The possibility of Pluto and Neptune colliding serves as a reminder of the universe's ever-changing nature and the significance of remaining vigilant in our pursuit of knowledge. Numerous researchers have investigated the complexities of planetary orbits and gravitational interactions in response to the possibility of a collision between Pluto and Neptune. Even though such an event is still highly unlikely, the potential repercussions are far too significant to ignore. Particularly, the study of Pluto's orbit has shed light on the delicate balance that controls the motion of the stars in our solar system. Scientists can learn more about the forces that shape the solar system by looking into the factors that keep Pluto's orbit stable. Predicting the long-term behavior of spacebound planets and other objects and devising strategies to mitigate potential risks require this knowledge. The investigation of Pluto's circle additionally features the significance of proceeded with exploration and perception in the field of cosmology. Scientists are able to improve their models of celestial dynamics and collect more precise data as technology advances. Our understanding of the universe and the security and stability of our solar system depend on this ongoing work. In the end, the possibility of Pluto and Neptune colliding serves as a reminder of the complex and frequently erratic nature of our cosmic environment. We must remain alert and prepared for any challenges that may arise as we continue to investigate the mysteries of space. We can learn more about the universe and work together to protect our place in it by working together and continuing our research.